Brief summary of the preceding. Rational function x plus 5 over x plus 7 squared. It's a rational function because it's a polynomial over a polynomial. In this case, a degree 1 over degree 2 polynomial. In any case, it's a rational function as long as you got a polynomial over a polynomial. In analyzing a rational function, we ask the obvious questions. When's the numerator 0? When is the denominator 0? We check the end behavior. What happens if x gets very large in the positive or negative direction? Okay, we find asymptotes. Now, we find vertical asymptotes when the denominator is 0. We find horizontal asymptotes when we find the end behavior. If there are horizontal asymptotes, it'll come out in the end behavior. Oblique asymptotes occur only if the degree of the numerator is 1 greater than the degree of the denominator. I wrote that as degree of numerator minus degree of denominator equals 1. We also want to find the y-intercept. For this function, the numerator is 0 when x equals negative 5. That's very easy to find. For the denominator is 0 if x equals negative 7. There are the details, very easy to find. The y-intercept occurs when x is 0, so we evaluate f of 0, and we get 5 over 49, giving us a vertical asymptote of, a vertical intercept, y-intercept of 0, 5 over 49. That's about 1/10, very small. We have 0 of the numerator. The denominator is not 0, so if we do numerator over denominator, it's 0 over something that isn't 0. So we get 0, meaning that the 0.50 is on the graph. At x equals negative 7, the denominator is 0 and the numerator is not. So we have a vertical asymptote at x equals negative 7. We notice that anywhere to the left of x equals negative 5, the numerator is going to be negative, so that we're dividing a negative here by something that approaches 0. And also, the denominator is never negative. The denominator is always positive, except at x equals negative 7, where it's 0. The function isn't even defined at that point. So that as we approach x equals negative 7, the denominator approaches 0 through positive numbers. The numerator is negative, so we have a numerator divided by something that approaches 0. The numerator is not 0. This is going to give us a very large result, and it's going to be negative. So we get this kind of an asymptote near the vertical line to the vertical line, x equals negative 7. The end behavior, large absolute value of x, implies that you have a very large numerator but a much larger denominator, so that the function is near 0. More and more so as absolute value of x gets larger. So the graph starts out at the negative asymptote here, comes through 5, has to go into the positive, but it decays here and begins approaching 0. And on the left-hand side, we have the vertical asymptote with the line x equals negative 7, the horizontal asymptote with the negative x-axis. And if you want more explanation, look at the preceding clip.